lecture reference. So divergence theorem. It's module 2. So last section we have studied flux across general surfaces. That means if we have given sigma, we are finding flux by using surface integral for general surfaces. Now in this section, here we will concerned exclusively with the surfaces that are boundaries of finite solid. For example, the surface of a sphere. That means we have to integrate over the surface of the sphere. If sigma, that is sigma may be a solid box or cube or a solid cylinder, etc. So now in this section we will study how to integrate or how to find flux across the surface of some uh, solids or finite solids. Okay. So now before going to that, we will recall what is divergence of a vector field. Do you remember divergence? This is
Yes,
divergence.
sir.
Divergence of a vector field f of x y z is equal to f of x I of x y j plus h of x y z k
Del dot F.
div x del dot f. Div f is del dot f. Dou f by dou x plus dou g by dou y plus dou h by dou z. And this is a scalar, right? Not a vector.
Yes, sir.
So now, before defining divergence theorem, let us do a problem of finding flux along a surface of a solid cube. That means നമ്മൾ ലാസ്റ്റ് ക്ലാസ് ചെയ്ത മെത്തേഡിൽ ഒരു ഒരു പ്രോബ്ലം ചെയ്യാം and we will do same problem using divergence theorem and you can find the difference and easiness. എത്ര ഈസിയാണ് നമുക്ക് ഡൈവേർജൻസ് തിയറം യൂസ് ചെയ്തിട്ട് ചെയ്യുന്നത്. So we will do a problem. Find the outward flux of the vector field f of xyz equal to 2xi plus 3yj plus this is not z2, it is z square k. Okay, z square k across the unit cube in the figure. So this is across the unit cube and we want to find out the flux integral. So what is flux formula? Is double integral over sigma f dot n ds, right? So this is
Yes, sir.
double integral over r. If the surface is of the form z equal to g of xy, then what is the formula?
Minus dou Z dou X Y.
Okay, f dot minus dou z by dou x minus dou z by dou yj.
Plus K cap.
Okay, dA. Now here there is a problem because here our surface is a cube, sigma is a cube and we cannot parameterize the surface directly. So what we will do is we will cut it into 6 pieces. That means we have to integrate separately on each edge. S5, S6. Okay. So how to do that? For S1, surface 1. Okay, what is S1 here? This is in the xy plane. So x z equal to എന്താണ് S1 ല് 0.
0.
Okay. And x ranges from
0 to 1.
1 and y ranges from 0.
0 to 1.
Now first we will find flux integral along this. That means if we want to find out the total flux, we will find flux across the 6 edges. So I will write double integral over S1 f dot n ds is equal to double integral, and I am calling this R1. Okay. Okay, so now 2xi plus 3yj plus z square k. So you can write 2xi. F is 2xi
plus
plus.
3y plus z square
Okay, so what is z here?
0.
0. So 0 k dot. Now what is dou z by dou x? Z equal to 0. Then what is dou z by dou x?
0.
0. Dou z by dou y?
Constant 0.
0. Okay. So 0 minus 0 I minus 0 j plus 1
Plus k.
d. Now what is this dot product?
0.
0.
0.
Okay. So the answer for that means flux along S1 is
0.
okay. So now you have to find out along S2. So what is S2? What is Z
അത്
here?
xy plane ലാണ്.
അതെ അത് XY plane.
Picture equal to 0.
Equal to 0 ആണോ? It's not in the XY plane. S2
അല്ലല്ല
is in
അല്ല
top.
it's 1 to 0 1 1 1 to 1.
Z equal to 1, right?
Yes sir.
To 1. And X ranges from 0 to 1 and Y ranges from 0 to 1, right? അതായത്
Yes
Z equal to 1 എന്ന് പറയുന്ന പ്ലെയിന് എക്സ് ഈക്വൽ ടു 0 എന്ന് പറയുന്ന പ്ലെയിനും വൈ എന്ന് പറയുന്ന പ്ലെയിനും കട്ട് ചെയ്യും. വൈ സോറി വൈ ഈക്വൽ ടു 0 എന്ന് പറയുന്ന പ്ലെയിനും വൈ ഈക്വൽ ടു 1 എന്ന് പറയുന്ന പ്ലെയിനും കട്ട് ചെയ്യും. ദാറ്റ് മീൻസ് ദിസ് ഈസ് Z equal to 1 is constant here, right? Z equal to 1 and X ranges from 0 to 1, Y ranges from 0 to 1. Now tell me what will be the flux S2 F dot n ds is equal to double. I'm calling this projection R2. Okay, so R2 F is 2xi plus 3yj plus z. What is z?
K.
K. K. 1 square, that is k dot. Here also what is dou z by dou x? 0, right?
0.
Dou z by dou y.
0.
So that is minus 0 plus k d. So this is equal to double integral over r
K. 1.
dA double
1.
integral 1. Okay, so here R2 is our in xy plane, it is 0 to 1, 0
xy
to
0 to 1.
so
1 dx. 1 dx equal
so this is equal to dx dy to 1, right?
1.
So the answer is 1. Okay, now we will find for S3. So tell me what is S3. S3 means this surface.
X is a plane.
This is a plane and y equal to
0.
0. Okay, y equal to 0. So y equal to 0. X ranges from 0 to 1. Y ranges from.
And is a range.
Now you have to find out S3 f dot n ds. This is equal to double integral over R3. Okay, so 2xi, right? Plus what is y?
0.
0. So 0 plus z, I think z square, right?
Yes, sir. Z square gate.
Now what will be this normal? It is of the form y equal to
Dou y by dou x
dou by okay, dou y by dou x, dou
minus
y,
dou y by dou x.
okay, that is equal to എന്താണ്
0.
0 I mine plus
അടുത്തത് 0.
അടുത്തതും
Dou y by dou z.
0 and next sorry, so this is actually minus dou y by dou x plus y is uh, j, right?
Yes, sir.
Minus
Dou y by
dou
dou
y
z.
by dou z. So this is actually dou y by dou x is 0 and this
Dou
is,
y by dou x 0.
so what will be this integral? 2x 0,
0 ആയിരിക്കും. 0.
so this is equal to,
0.
now for what we will get for s3, s4, s4 is actually here, right? This s4 and the two here
1 by
y equal to 1, okay, y equal to 1, 0 less than or equal to
അതിന്റെ ആൻസർ 1 ആയിരിക്കില്ല ചെയ്യണം.
അതിന്റെ ആൻസർ 1 ആണോ 2 ആണോ? Okay, I will stop from here. Okay, 0 less than z less than 1. So now we can find s3 f dot n ds. This is equal to double integral over r4 2xi plus y ന്റെ കോഎഫിഷ്യന്റ് എന്താണ്? This y's coefficient, right?
Yes, sir.
3j plus z square k, and our this is minus dou y by dou x I plus j minus dou y by dou z k. So what is dou y by dou x? 0, and dou y by dou z 0 because y is equal to 1. So dou y by dou x is equal to 0, dou y by dou z is equal to 0. So what will happen in this integral? 2xi into 0, 0 I plus 3 into 3j
3
dot
into
j, 3 plus 0. Sorry, here no I, right? 0, 0. And
dA.
and if we integrate 0 to 1, 0 to 1, 3 dA, which is equal to 3. Okay. Similarly, ഇനി നമുക്ക് S5 and S6 കണ്ടുപിടിച്ചൂടെ? S5 for S6,
Yes, sir.
S5 ന് 0 കിട്ടും because x equal to 0 ആയിരിക്കും surface. Okay. And similarly for S6 we will get this answer will be 2. S6 f dot n ds will be 2 because it's 3 coefficient of this. So total flux
9.
എന്തായിരിക്കും? We get first
9.
S0 plus 1
1 plus 3.
plus
2.
so 6, right?
6. Yes, sir.
I've done a lot of calculations here, right? So that is the difficulty in finding flux integral in usual method. So now we will define divergence theorem. So the divergence theorem tells us, let G be a solid whose surface sigma is oriented outward, and if f of xyz is equal to f of xyzi, g of xyzj, h of xyzk. F, G, H have continuous partial derivative on some open set containing G, and N is the unit outward unit normal on sigma. Then double integral over sigma f dot and ds is equal to triple integral over G
പക്ഷെ അപ്പൊ
diverge.
ലാസ്റ്റ് കേസ് നമുക്ക് ഇൻവേർഡ് ആണെങ്കിലോ നോർമൽ നമുക്ക് ഈ ഡൈവേർജൻസ് തിയറം
വേർഡ്
അപ്ലൈ ചെയ്യാൻ
ആണെങ്കിൽ
പറ്റില്ല.
ഇല്ല ഡൈവേർജ്
അപ്പൊ
പക്ഷെ
അതേ ചെയ്ത പോലെ തന്നെ ചെയ്യണം.
അതേപോലെ ചെയ്യണം. പക്ഷെ എക്സാം ക്വസ്റ്റ്യൻസ് അധികം ഔട്ട്വേർഡേ തരും, ഇൻവേർഡ് നോർമലി ഉണ്ടാവില്ല. കാരണം ഇതൊരു സർഫസ് ക്ലോസ്ഡ് സർഫസ് ആയതുകൊണ്ട് ഔട്ട്വേർഡ് നോർമലേ തരുള്ളൂ. we have to find integrate over the surface. Okay. ഇൻവേർഡ് ആണ് തന്നെങ്കിൽ ആ മെത്തേഡിൽ ചെയ്യേണ്ടി വരും. Okay. Normally we will get outward unit normal. Okay. So this is the triple integral over G. So now we will do the same problem by using divergence theorem. So solution. So what is here f of x y z is, so divergence theorem to find the outward flux of the field f of x y z is 2xi plus 3yj, and this is z square k across the unit cube. Okay, same question. So we will use divergence. So first we will write f of xyz 3yj plus z square k. Now what is divergence theorem?
ട്രിപ്പിൾ ഇന്റഗ്രൽ ജി
Double integral of sigma f dot and ds is equal to triple integral over v div f dv.
dv.
So first we have to find out divergence of f. So tell me what is divergence of f.
Del of
Del del
2
del dot f,
2
right?
plus 3 plus
2
2 is
2
3
plus
plus 2 is
plus 2
3 is
3 is
2 is 2 is 2
2
is
2 is okay. Let me now this is 5. Okay, we will do this 2 is it, right? Now okay, now we will find triple integral over v 2 plus 3 5 plus 2z 2z dv, right? Okay. Now what are the limits of integration? What about z? There are
unit
3,
cube and 0 to
0 to 1, right? This that means this is the surface, so z ranges from this is 0,
0 to
z
1
equal to 0, z equal to 1, so 0 to 1, y 0 to 1, and x 0 to 1.
0 to 1
And if you calculate 0 to 1, 0 to 1, 0 to 1, okay, 5 plus 2z, so 2z square by 2, right? 0 to 1, so z and
6
z.
and sir
So this is 0 to 1, 0 to 1, 6
6
d.
dx dy
Okay, dx dy. So if you calculate this, you will get the answer
6
as 6. So so now the integral becomes very easy. Okay, so now you do another problem. You try to do use divergence theorem to find outward flux of the vector f of x y z is equal to 3x cube I plus y cube j plus z cube z square k.
പാരാമെട്രിക് ഫോം ചെയ്യണ്ടേ സർക്കിൾ ആയതുകൊണ്ട്?
No. We will use the divergence theorem. Okay. Across the surface of the region enclosed by the circular cylinder, x square plus y square is equal to 9, and it is cut by the plane z equal to 0, z equal to 2. So something like this our figure. Okay, this is circular cylinder. X square.
സർ താഴെ സർക്കിൾ ആയതുകൊണ്ട് നമ്മള് എക്സിന്റെ വാല്യൂ മറ്റേത് ചെയ്യണ്ടേ, പാരാമെട്രിക് ഫോം ഇടണ്ടേ ഉദ്ദേശിച്ചു?
That means polar ഫോമിലേക്ക് മാറ്റാൻ.
യെസ് സർ.
അത് നമുക്ക് ചെയ്യാം. അത് ലാസ്റ്റ്. So this is cut by z equal to 0 plane and z equal to 2 plane. Z equal to 2, z equal to 0. Now solution, we want to find out the flux, right? So flux is double integral over sigma f dot n ds, and we have f is equal to x cube I plus y cube j plus z square k. Okay. So z square k. Now we will use divergence theorem. Why we can use divergence theorem? This is a circular cylinder and the whole surface, right?
Yes.
Okay. Divergence theorem is, we know that double integral over sigma f dot n ds is equal to triple integral over v div f dv. Now you find out divergence of f. What is the
3x square plus 3y square plus 2z.
x square plus 3y square plus 2z. Okay.
Z.
Now we will find double integral over sigma f dot n ds is equal to triple integral over v div f is 3x square plus 3y square plus 2z dv. Now we will find the limit of integration. So dv means it is in triple integral. അപ്പം നമുക്ക് x y z ഉണ്ടാവും. First we have to find out the limit of z.
0 to 2.
0 to 2, right? Because it is cut by the plane z equal to 0 and z equal to 2. So 0 to 2. Now if we project into the plane, what you will get in xy plane? X square plus y
Circle.
square is, it's a 9, right? Circle. X square plus y square.
Radius 3.
So radius 3. Then we can use polar form. That is better, right? So what is this? R equal to
0 to 3.
3, right? Okay. So R equal to 0 to 3. 0 to
Theta is equal to 0 to pi.
0.
2 pi.
Theta equal to 0 to 2 pi. Now, okay. Now this we can written as integral 0 to 2 pi, 0 to 3. Always we will do z as first integral. 0 to 2, 3x square plus 3y square plus 2z dz r dr d theta. Can you do this problem and tell me the answer?
Yes, sir.
I will give you time. Please integrate and tell me the answer. Otherwise, I will. 3x square plus 3y. 217 and pi, I think, will be the answer.
Yes, sir. 275 by
217 and pi.
5.
217 and pi. So this is the answer.